Hey everybody, it's Miss Moran and I'm back to talk about an entire new unit of study, fractions. This is some of my favorite math of the year, but don't you worry if you enjoyed multiplication division. We're going to continue using that all throughout these chapters. We'll have 3 units on fractions and then 1 follow-up unit on decimals, which is related to fractions. So the first thing we need to do is make sure we understand what a fraction really is, and make sure that we can take what we learned about in 3rd grade with fractions and extend it a little bit in 4th grade. So first thing we want to think about is, what is a fraction? It's really just a division problem that shows us how to take a whole and break it up and take part of that whole. The most important part of that fraction is that bottom number. We call it a denominator, but even more than just knowing what the denominator is, it's important that you understand what it is. Most students incorrectly think that it means a total, and it doesn't mean a total. It's how many parts the whole is divided into. It's your division problem. How many parts are you going to make your whole? Sometimes that includes a total number, but a lot of times, especially in 4th grade, it does not. And when students come from 3rd grade, most of the time that bottom number was a total number of parts, so we want to get away from that misconception. The top number is how many parts to count or how many parts to shade. We call that a numerator. But you can't shade any parts until you know how many parts to make. So that's why I say this bottom part is the most important part of the fraction. So we're going to look at a couple different examples of what a fraction can look like and how it can be represented using models. So we can do part of one whole thing, such as part of a pizza, part of a cookie, part of a pie. So if I have part of one whole thing, I'm going to decide, what do I want my whole thing to look like? A lot of times we'll use square or rectangle models. We can even use number line models. In this case, I'll use a circle. I'm going to split my circle into 4 equal parts. So I don't want to split lines here because that would make some uneven parts on the side. So to make that equal, I'm going to split it into 2 parts and then into 4 parts. All right, that numerator of 2 means I'm going to shade in 2 of those parts. So to give myself 4 parts, which is what my denominator is, how many parts I'm going to divide the whole into, and then my top number, my numerator, how many parts I'm going to count, 2 out of the 4. Very simple fraction of 2/4. Now when I get to 1/5, I want to be careful about using a circle because most students have not been working with these for very long, and it's hard to take a circle and break that into 5 equal parts. It's an odd number, so you can't split it in half like this one and then turn those 2 parts into 5. So a better model for that might be a rectangle model. So I'm going to take my whole, split it into 5 equal parts, which will be 4 lines. Okay, and then I'm going to shade in one of them. Okay, so that shows my fraction 1/5. All right, and then my last one I'm going to look at is 5/6. I can split 6 into a circle. I can do 6 pretty easily. I could also do it as a rectangle model. We could even do it as a number line model, which I'll show you. So 6 are a little bit trickier. Sometimes students want to go this way. Once you get to 4, you're not going to be able to turn that into 6. So we want to split each of our 2 parts into 3. That'll give us 6 parts. And we're going to shade in 5 of those. Okay. You could also do a rectangle model. You could do like I did here, or you could even do this in 2 rows. I'm going to shade in 5 of those parts. Okay. And then again, if you wanted to make a number line, you could split your whole into 6 parts. 1, 2, 3, 4, 5, 6. 1 part, 2 parts, 3 parts, 4, 5, and 6. It's not 6 lines, it's 6 parts. If I want to shade in 5, 6 of those, 1/5, 1 6, 2 6, 3 6, 4 6, 5 6. So that would take up from 0 to 1 whole. This would be 5 6 of the way there. Okay, so 3 different models for showing part of one whole thing. Now we're going to learn in 4th grade, and this is different from 3rd grade, is that part of one whole thing can also be a group. And that can be a simple group, like 3/8, showing that I would have 8 parts. And I'm going to count 3 of them. Okay, seems simple enough. Whoops, this one went too far. 3 out of the 8. Or this one gets a little bit trickier, and so I put a star by this. So I'm going to make 1/4 of this group, but this doesn't have 4 things in it. This has 12 things in it. So this is where students get hung up, not understanding what the denominator means. Remember, the denominator is how many parts your whole is divided into, not how many total items you have. So this 1/4, all that means I need to do is make sure that this shows 4 parts instead of what it has now. Right now it looks like 12 parts, so I want to put this into 4 parts. This is where my division comes into place. 12 parts split into 4 groups. It's going to be 3 in a group. So that's 1 part, 2 parts, 3 parts, and 4 parts. So even though it's 12 items, now I'm looking at it as a fraction of fourths. I want one of those 4 parts shaded in. So that's this entire section. That is now 1 part out of my 4 parts. Okay, here's another example of that. So this is 3/5, but again, I don't have 5 things. I have, this is 10 things, but this is still 1 whole because it still is 1 group. It could be like it could be like 10 people. It could be 10 animals, it could be 10 hair bows, whatever you want it to be. And it's still 1 group of a collection of items. So 1 group of people, 1 collection of hair bows. So if we want to make this fifths, we want to make this 5 groups. Not 5 in a group, but 5 groups. This is 10, so in order to make 5 groups, I need to put 2 in each group. This is where our division from last chapter comes so much into play. So now I have fifths, and I'm going to shade in 3 of them. Not 3 items, but 3 of my fifths. It's 1/5, 2/5, and 3/5. Okay? One other thing we're going to get into is mixed numbers. Okay, what is a mixed number? Almost exactly what it sounds like. It's a mixture of a whole number and a fraction. So if I wanted to show the fraction 2 1/3, what does this mean? Well, it means that I have 2 wholes, and then I have part of another. Each whole is going to be broken into the same number of parts. Okay, so over here, the denominator is how many parts the whole is divided into. So all of these wholes are divided into 3 parts, and I'm going to shade in 2 whole parts, or 2 wholes, and I'm going to shade in 1/3 of this other. Okay, so this can be written as 2/3. It can also be written as what we call a fraction greater than 1. So I'm dealing with thirds. How many thirds do I have altogether? 1, 2, 3, 4, 5, 6, 7. So 7/3 is another way to show 2 1/3. We call this a mixed number. We call this a fraction greater than 1. This used to be known as an improper fraction, but we've kind of gotten away from using that term because there's nothing really improper about it. Students often think that the number on the bottom has to be the larger number, and the number on the top has to be smaller, and that shows they don't really understand what a fraction is. All a fraction is showing us is how we break up a whole and how many parts we wish to count. So it's okay that this number on top is larger. That just means we have 7 of those pieces to count. All right, we'll do another one. If we had 3 1/4. Okay, again, so each whole broken into fourths. So there's my 3 wholes. I need another one, still broken into fourths. We're going to shade in 3 wholes completely, and then 1 little piece in this one. Okay, so these are fourths. How many are there? I could count 1 at a time, or I could skip count. This is 4, 8, 12, and 1 more makes 13. Now, you can also do this in reverse. If I gave you 9/5, what does that mean? How do we model that? Well, that means that each whole is broken into 5 parts. Again, making a circle is sometimes a little bit trickier to do your equal fifths there. And we're going to shade in 9 of them. So this is only 5 of them. That tells me this is going to be more than 1 whole. That's why it's a fraction greater than 1. So shading in the whole is going to be 5/5. Okay, so then my next whole is going to need a total of 9. So it's 5, 6, 7, 8, 9. Okay, so what does that equal to? Kind of went a little too far there. That one's not supposed to be shaded in. Okay, so 5 and then 4 is going to be 1 whole and an extra 4/5. So if 5/5 makes my whole, this is 4 over that whole. All right, we'll do 1 more of those. We'll do 5 halves. Okay, so 5 halves. Each whole is going to have 2 parts. Obviously, 5 of them is going to be way more than 1 whole. So it takes 2 halves to make a whole. Okay, 2, 4, 1 more makes 5. Okay, so 1, 2, 3, 4, 5 halves, which is also equal to 2 wholes, and 1/2. Okay, so mixed numbers and fractions greater than 1. All right, thank you so much for watching. Stay tuned because in just a couple days I'm going to send out my next fraction video on equivalent fractions, which we'll be spending the rest of the week on. All right, thank you so much for watching. Go ahead and like and subscribe if you haven't already. Thank you.